What did the complementary angle say to the right triangle? Nice legs. Get it? Legs on a right triangle, and then the angles are complementary. Anyways, we are talking about angle relationships and triangles, and there are a few things we should talk about. First of all, what is an interior angle? So if we have an interior angle, that is pretty much any angle that is interior or inside of the triangle. So there's an interior angle there. Here's an interior angle right here. An exterior angle is formed when you extend one side of the triangle and you go outside of the triangle. So if I go ahead and change the color a little bit, and this angle right here would be an exterior angle. So you can see it's outside of the triangle. Adjacent means next to, and a remote interior angle is an angle that is not adjacent to an exterior. So if I go ahead and show you the exterior angle again, so that's what we highlighted in the prior slide, and then I wanted to show you a remote interior angle, and I'm only worried about doing one right now. I could use this angle, or I could even use this angle. Both of those are remote interior angles because they are not touching. They are not next to this exterior angle. Finally, an auxiliary line is a line that is added to a figure to help you in a proof, kind of like when I extended that line on those triangles to make exterior angles. And a corollary is a theorem whose proof follows directly from another theorem. So in a way, it's a new theorem from another theorem. So we'll see how, I'm not going to be that picky between corollary and theorem. But let's go ahead and go to the triangle sum theorem, which you know you learned in 6th grade. It says the sum of angle measures in a triangle is 180 degrees. Why is that? Well, I know with my 6th graders, one thing I tried to do was construct, take a triangle and rearrange it so that all the corners were together, and you could see that it made a straight line, which is 180 degrees. The triangle sum theorem, some of the corollaries are that acute angles of a right triangle are complementary. So let's see how this works. I have triangle ABC. It's a right triangle. And so I know that all three angles have to add to 180. Measure of angle A plus measure of angle B plus measure of angle C. Now I know measure of angle B is 90, so I substitute that in. Then I subtract 90 from both sides, and I get measure of angle A plus measure of angle C equals 90. Well, that's the definition of complementary angles. So what that means is in a right triangle, the two other angles, the acute ones, will always be complementary. Now, another corollary is that the measure of each angle of an equiangular triangle is 60 degrees. Equiangular means that all angles are equal, so I label them all with X. If I add all the X's together, I should get 180 because there are 180 degrees in a triangle. Combine like terms, and I get 3x equals 180. Divide both sides by 3, so x is 60, which means that it doesn't matter about the size of the equiangular triangle. It will always have three 60-degree angles. The exterior angle theorem says that the measure of the exterior, which is right here, is always equal to the sum of its remote interior angles, which kind of makes sense because I know 3 plus 4 has to be 180. And I know 3 plus 1 plus 2 has to be 180. So I could substitute in and say, get that angle 4 equals angle 1 plus angle 2. Let's go ahead and apply the exterior angle theorem. Now I'm going to say angle 4 is 123 and angle 2 is 51. So using that, I know measure of angle 4 equals measure of angle 1 plus measure of angle 2. Substitute in what I know. Then I can solve for the measure of angle 1 by subtracting 51 from both sides. and I get 72 is the measure of angle 1. Now I'm going to, in example 2, I'm going to use the remote exterior angle theorem to find angle BDC. Why? Because it's an exterior angle to this triangle. So I know that this exterior angle equals the sum of these two remote interior angles. I just add them together and I get 69 as my answer. Now I'm going to find angle DCB, which is the green one right here. Well, 36 plus this 90-degree angle right there, plus our mystery angle C is 180. Combine like terms, and then subtract 126 from both sides, and I get measure of angle C is 54. Now we're going to do another one where we're going to find the measure of angle BAC, or really just the measure of angle A. So let me go ahead and show you in highlighter. Measure of angle A in terms of x. Well, I know that my exterior angle, which is the 3x minus 10, is equal to the sum of the two remote interior angles, this angle A plus angle B. So you can see I have DCB equals measure of angle A plus measure of angle B. Substitute in what I know. I know that the DCB is 3x minus 10, and angle B is 120 minus 2x. So here's the 3x minus 10 and the 120 minus 2x. Now I'm going to move everything over because I'm trying to solve for measure of angle A. I'm not really solving for x. So I'm going to add 2x to both sides and then subtract 120 from both sides. So I get 5x minus 130 equals the measure of angle A. Now, example 4, one of the acute angles in a right triangle measures 72 degrees. What is the measure of the other acute angle? Well, we know that acute angles in a right triangle are complementary, so I don't have to worry about the right angle here. I can just look at the two small ones, and I know they have to add up to 90. So 72 plus the other angle must be 90. Subtract 72 from both sides, and I get 18 as the other acute angle. The third angles theorem says if two angles of one triangle are congruent to two angles of another triangle, the third pair of angles are congruent. And I'll show you why that is. I've created two triangles here, and you'll notice that they are different sizes. But what they do have in common is that two angles are for sure congruent. I have alpha here, which is 24 degrees, and that is congruent to this angle over here, which is also 24. Beta and epsilon are congruent. Now, the third angle I did not constrain. It pretty much is saying, well, I have to make all three of these angles add up to 180 degrees. So if I have 24 and 50, the only thing I can have here is 106. The third angle theorem says that if two angles are congruent to another set of two angles, then the pair of third angles are also congruent. So let's say I change this angle a little bit. Again, you can see the triangles are different sizes. But since these two green angle pairs match, the red angle pairs have to match. And the reason that is that they always must sum to 180 degrees. Now let's look at example 5. I'm trying to find the measure of angle P and the measure of angle T. Well, I know that these angles are congruent by the third angle theorem because angle N is congruent to S and angle M is congruent to R. So I can just say angle P is congruent to angle T. Now I'm going to substitute in this 2x squared in for P and this 4x squared minus 32 in for T. Now I'm going to solve for x squared. First of all, I'm going to do something weird. I'm going to subtract 2x squared from both sides. And I get 0 equals 2x squared minus 32. Now I'm going to add 32 to both sides because I don't want the 2x squared with the number. and I get 32 equals 2x squared. I can now divide both sides by 2 using the division property of equality, and I get 16 equals x squared. Taking the square root of both sides, I'm not going to have a negative angle, so I just take the positive, and x is 4. Substituting back in to find my angle, I get 2 times 4 squared, or 2 times 16, which is 32. Both angles have a measure of 32 degrees.